Hey guys, this is Mr. Sal. We're looking at this Unit 6, Section 1, Introduction to Integers in this lesson. So right in the middle of the coronavirus breakout, and hopefully everyone's staying safe out there and healthy. Take care of yourselves, alright? So hopefully this video helps you guys out. So just real quick, integers, right? So we've already dealt with a couple different types of numbers, and I'm going to use the number line to demonstrate this. In the past, we kind of started at 0 and then we worked to the right. Right, so each one of these marks would represent 1. So this would be 5, and then, you can go as far to the right as you want. I'll go as far as 10. And these are all considered positive numbers. The numbers to the left of 0, though, those are negative numbers. So this first mark would be considered -1, then -2, -3, -4, and then we would have -5, -6, -7, -8, -9, and then -10. And this line goes in infinitely in both directions. So a negative number is any number that is less than 0. On the number line, we would describe it as any number that is to the left of 0. So since it's both to the right, which is positive, to the right of 0, left of 0 is negative. This means that 0 is neither positive or negative. Now that's not super important to remember. It's just kind of a fun fact, I guess, if you will. So integers include all of these numbers, including 0 actually. So we could say that -10 is an integer, -9 is an integer. We could go all the way to 0, and then we could start at 1, 2, and 3, and go all the way up to 10. And of course this goes infinitely to the right, but also infinitely to the left. Now they've shown it as a set down here at the bottom, right? And the 3 marks here indicate that it goes infinitely to the left and then also infinitely to the right. So one thing to remember about integers is it does not include decimals, nor does it include fractions. Now, yeah, we could write these all as decimals and fractions. That's not really what I'm talking about. We just don't need to write them as fractions or decimals. Let me explain that a little bit more. So if you had seen a fraction like 1/2 or 1/4, or even a negative fraction like -8/10, right? None of those are integers because they are a proper or even an improper fraction, for that matter. Mixed numbers are no good. We just want whole values, okay, and then what's considered their opposites, which would be the negative values. So if you're ever confused on how to tell if values are positive or negative, and we'll write these as signed numbers, but these are some ways to know. So like negative numbers, right? We usually consider debt to be negative. Like if you owe someone $5, then you would have -$5. And I'm not too worried about the positive values here. Those are usually self-explanatory. We've been dealing a lot with those, okay? So I'm just focusing on these ones here with the negative numbers. The temperature, this is below 0 degrees, right? Like as soon as you get below 0 degrees, it's freezing, it's pretty cold outside, that kind of thing. Elevation, right? When you get below sea level, you're considered in the negative, elevation level there, okay? Or also reverse or going down. You could also consider something like taking away, right? Like if you take away something, then you're pumping in negative values into that. Now, none of those have to make complete sense. We'll look at some of these exercises to figure out what's what. Okay, so just to start out with these examples here on the left. So we just want to express each of these as positive or negative values, right? So an airplane flying at 25,000 feet, since it's flying it, of course it wouldn't be underground, right? Because the ground level would be considered 0, so this has to be a positive value. Now this one says the coldest recorded temperature for Provo, Utah is 20 degrees Fahrenheit below. Now since it's below, that is what would make it a negative 20. Or if you have a student loan that's currently at this much, again, that's how much you owe. Therefore, it is also considered a negative. So let's assign some values to these ones, okay? So the lowest point in the United States is Death Valley, California. That sits at 282 feet below sea level. So this one is below sea level. Since it's below sea level, I know it's going to be negative, and then I can simply write the value there, 282. Now, if you want to label this as feet, that's okay. But we're just looking for the integer or the number itself that represents it. So it's not necessary that you label these specific problems. Next up, Death Valley is also the hottest place on Earth with a record high temperature of 134 degrees Fahrenheit. So since this one is a high temperature, we know it must be above zero. So it's going to be a positive 134. And again, I don't really need to label this, okay? Now, the interesting thing about positives is if we showed the positive sign for all positives, would get kind of sick of it, okay? So just keep that in mind. We don't really need the positive. Now, right now, if you want to show it, that's okay. Just keep that in mind in the future when we say positive. We don't usually show the sign as positive. Next, at mail time, you are delivered a bill for $24. What is your net worth? Since this is a bill, it's something that you owe. Therefore, this is a negative value. So this would be negative $24. Your net worth would be negative $24. But again, we're just asking for the integer here, the number, which I'm going to write as negative 24. Alright, when we're graphing numbers on number lines, it really is just as simple as finding the number on the number line. For example, on the left here, right, it says graph negative 2, so we find negative 2, bam, we put a dot there. Graph negative 3, bam, you find negative 3, put a dot there. So over here where it says graph negative 4 and 1, I'm just going to put 2 points on the graph. You can put as many points as you need to, but just one for each number. So when I'm going to find negative 4, I found it, I'm going to put a point there. Next, I'm going to find 1 on the number line. There's 1. So right there, I'm going to put a point on that line on the number line. Next up, it says to graph negative 1, so I'm going to start with that one. I know there's a 2 there, but I'm just going to start with negative 1. I found it. Next up, we're going to graph 2, so I find it on the number line. Bam, graph it. And this is how you would graph numbers on the number line, and we kind of demonstrated that at the beginning of this lesson. Now next up, our objective here, use less than or greater than to write a true statement. So for any whole numbers a and b, if a is less than b, it's red, and I'm up here at the top, is red as a is less than b. And it's true when a is to the left of b on the number line. Think left is less, so double L thing right there. 2, this would read a is greater than b, and is true when a is to the right of b on the number line. So again, we look back at this like the alligator thing, right? It's going to eat the number that is bigger. Well, how do we know what number is bigger? Specifically, we're looking at numbers to the right on the number line. So it's going to eat the number farthest to the right on the number line when we think about it this way. So we go through these examples. We see that 9 here is less than 7 because 7 is to the right of 0, negative 9 is to the left of 0. Now you may look at this and think, well, negative 9 is bigger though, right? Well, maybe its whole value is like its absolute value, but 7 is farther to the right on the number line, and that is what we're really concerned about, okay? And on this one, well, why is it eating the negative 4? Isn't 4 smaller than 11? Well, 4 is, but negative 4 is not smaller than negative 11. Because if we looked at a number line, this is where 0 would be, negative 4 would be here, negative 11 would be here. See how negative 4 is to the right on this number line? That's why it's eating the negative 4. So again, it may be helpful to think about these in terms of number lines. Like this next example, right? I look at 0 and negative 5. 0 is generally right in the middle, but I know negative 5 is to the left of 0 because it's negative. So, since 0 is to the right of negative 5, it definitely is bigger, therefore this would eat the 0. Let's look at this in different terms, alright? Now, again, I'll still use the number line just to kind of demonstrate this. This is where 0 is, and I always identify where 0 is on the number line, just so I'm not forgetting how the values are situated on the number line. I always relate it to 0. So I'm looking at negative 2 here. Negative 7 would be farther to the left because it's a bigger negative. Now this means that negative 2 is bigger. And so yes, from there we could answer the question. But again, I said I'd do this in different terms. Well, how can we look at this differently? It's like money, right? Now we know money when we look at this in terms of negatives, we think of money as debt or owing people money. So would you rather owe someone $7 or $2? Well, hopefully the answer is neither, and that would be great. Just if you had to choose between these two, hopefully you're going to choose to owe someone $2 instead of $7. All right. So that's the big difference on this one. Let's again use a number line for this next problem. 6 and negative 9. So this is where 0 is. 6 would be over here. Negative 9 way out there to the left. And again, we see that 6 is to the right of negative 9. So it has to eat the 6. Now again, if we relate this in terms of money, you could either have $6 or you could owe someone $9. Which one would you rather have? And yes, hopefully the answer to that question would be $6. Now we use the number line to order these from least to greatest, and we have that example there. But let's look at this example for us. So we're ordering these from least to greatest. Now if it helps you, you could draw a number line right here. Now I would just put 0 in the middle. And these don't have to be proportionally far away from each other, right? And yes, I'm putting 0 in the middle. That doesn't mean it's going to be the middle number. I'm just putting it here. So if I looked at these numbers, I would focus first probably on the negatives, okay? So I have negative 3, negative 15, and negative 9. Well, negative 15 is the bigger negative, which means it's farthest to the left. So negative 9 would be next, farthest to the left, and then negative 3, about right here maybe, okay? So I see from this list that we would have negative 15 is the smallest, negative 9 is the next smallest, negative 3 is the next smallest, and there's no other negatives, which means that 0 is the next number in this list. Now I look to the positives, and I've only got two of them, right? 6 and 8, and I know 6 is less than 8 because it's farther to the left on the number line, so the next in order from least would be 6, and then our greatest number in this list is 8. And this would be the answer for this problem. Now I had talked about absolute values in one of the examples before. This is what an absolute value is, okay? Find the absolute value, that's our objective. Before we do that, it's important to notice that this symbols right here is the absolute values. Well, what is an absolute value? An absolute value is a distance that a value is from 0 on the number line. Now, you may think about this, well, what about negative values? Again, we can think about this in terms of how far away it is from 0, right? So let's just look at an example down here. I'll make up a new example. Negative 5, right? So the question for absolute values really becomes, how far away is it from 0? And this really is the question for all absolute values of this type. How far from 0 is negative 5? Now, if you said, well, negative 5 is negative 5 from 0, it's not necessarily that you're wrong, but it's just not the absolute value of that. Okay, so it's like saying, if you owe someone $5, what was the actual value of what you owed? Well, it'd be $5, right? So That's why this comes out as a positive. Now notice I haven't used the word opposite. It's not an opposite thing. Okay? Keep that in mind, because it's one of the mistakes a lot of students make when we look at absolute values. Okay? So it's how far away is it from zero? So it's really talking about a distance, like it says here in the explanation above. And how often do you really refer to distances as negatives? I really hope you don't. I mean, unless you're really trying to trick people, in which case maybe you'd make a great politician, all right? But in any case, if we looked at distance, right? Again, if you talked in distance in negatives, like maybe you live negative 40 miles north of here. Do you hear any people talk like that? Probably not, okay? And if you did, you'd probably look at them weird and ostracize them and be mean to them in ways you shouldn't. But we want to be nice to people, but we also want to be more clear about what we're talking about. Instead of saying I live negative 40 miles north of here, you'd probably just say I live 40 miles south of here, right? So, in that case, we always refer to distances as positives. Let's look at another example. So if I said the absolute value of, we can use, well, I'm not going to use decimal, but it doesn't even have to be a small number, 1,234. Now again, this is asking how far 1,234 is from zero. Well, 1,234 is 1,234 units away from zero. It's just positive, okay? Again, that's because this is a distance. We don't talk about distances in terms of negatives. So in these examples to the right, again, we would say the absolute value of 14. How far away is 14 from 0? It's 14 from 0. How far is 0 away from 0? It's 0 away from 0. How far is 20 away from 0? It's 20 away from 0. And finally, how far is negative 2/5 away from 0? It's 2/5 away from 0. Okay? This literally is that simple. Again, it's not an opposite thing. We never see negatives come out of the absolute value. Now, there's ways we can get negative answers from them, but not out of them. And there's a very, very distinct difference between the two. So this leads us to opposites. And here our objective, find the opposite of a number. So opposites are two numbers that are the same distance from 0, but in opposite directions from 0. And the notation for opposites is just, it's either positive or negative, all right? So the opposite of a negative is, of course, a positive value. So give the opposite of each of the following numbers: 5, 7, 1, negative 5, and 8. So they've listed all of the opposites of these, okay, for us. But let's go to this example. Like 8, right? If I wanted the opposite of 8, I would take that 8 and just give it the opposite sign. Now, again, we don't usually show the positive values, but this one had a positive sign with it. It's just we don't show positive signs. So the opposite would be the negative. 0 is neither opposite or negative, so there is no opposite for 0. Now, if you were like, well, I don't really like that idea. Well, remember, it's a number that's the same distance from 0 in the opposite direction. Well, 0 is 0 in the opposite direction, so you could just say 0 is its own opposite if you'd like. So the opposite of negative 4, again, I take the number, but I switch the sign to be positive now. Again, I don't really need to show that positive, but if you'd like to, you may. And then we get the 11 here. Again, the negative would make this a positive 11, which don't really need to show that sign. So this would be all these numbers and their opposites. Alright, up here it says to simplify each of these followings. Now, one thing I'm going to say on this, I guess I'm going to explain it the way that most people don't like first, and then I'm going to explain it a different way which most people are kind of familiar with at this point. So an opposite tells us to take, a negative tells us to take the opposite of whatever's inside a set of parentheses. So if I looked at this example, I would say the opposite of negative 3. So I would think to myself, what is the opposite of negative 3? Well, the opposite of negative 3 is 3. So that's why this comes out as a positive right here. Now, back in the day, they probably said something like 2 negatives make a positive, which is okay as well. Right? So if you wanted to show that just as a positive 3, it becomes a positive 3 right there. So if I saw this first example, I would say the opposite of negative is positive. Positive 7 would be the answer on this one. Now this next example has 3 negatives, so it's the opposite of negative 8. Now we probably don't like that very much because we get a little confused when there's too many opposites, right? Like when we talk in terms of double negatives, we start to get a little confused anyways. That's why I just make this a big plus sign or a positive symbol right there. Now that's the 2 negatives. When we see 2 negatives like this, that is what gives us a positive, okay? 2 negatives will cancel out mathematically into a positive. Not in real life, though, okay? This does not work in real life. Like if you were to rob a store and then go rob a bank, it doesn't make it positive, okay? So don't try to use your math. I know you guys don't do this, but don't try to use math to do bad things. So what do we get? We got, now it's the opposite. The negative is the opposite of the positive. So this ends up being simply a negative 8 on this one. Now on the other hand, if we just looked at it with this positive right here, and we didn't think about this as a negative, we didn't think about this as an opposite. It's a negative, right? This is a negative. Just take the negative of 8, negative 8. Bam. So how does this relate to absolute values? You can see the answer right there. Just be careful with it, all right? Ignore this negative for now, all right? Just focus on the absolute value of negative 6. Well, what is the absolute value of negative 6? Again, the real question would be how far away is 6 from 0? Negative 6 from 0. It's 6 away from it. But then you had this negative out here in the front of it, right? So it applies to our final answer, which makes this a negative 6. So when I see an example like this one, again, I take the absolute value of 5, which is 5, but I can't forget about the negative here in the front, which stays with the answer, negative. And this is what I was talking about with the absolute values. What I got out of the absolute value was positive 5, but the negative was in front of it, was never inside that absolute value, so it doesn't apply. The same with this next example. I'm going to take first the absolute value of negative 24, which is 24, right? But I can't forget about the negative that was on the outside of the absolute value and apply it to the answer, which makes this now a negative 24. All right, it's important for you guys to see the difference between these two and the absolute value examples we did before, which we kind of did here in the bottom parts of these, okay? But if you have a negative hanging out on the outside of the absolute value, it applies to the answer. Alright, so in this next example, we'll write less than, greater than, or equal to make the statement true. Now again, generally we would be looking at a number line to compare these, right? So I'm going to look at these examples here on the right first. We have those ones on the left, and you can look at those. But I really want to compare these ones. Now I'm going to take their actual absolute values. The absolute value of negative 11 is 11. And then the absolute value of 6 is 6 away from 0. So I get 6 out of that. And we do have to do some evaluation on these. Well, which is more, 11 or 6? 11 is bigger than 6. It's farther to the right on the number line. Now what about this next example? Well, the absolute value of negative 17 is 17. It's 17 away from 0. Well, how does that compare with 17? in this case, it's equal. So if it's the same number, like we just saw right there, then it becomes an equality. But on this next example, the absolute value of negative 4 is 4, which we would then compare with 5. And which one is more? Which one is farther to the right on the number line? 5 is farther to the right on the number line. So this would give us the 3 answers to these problems. Alright, now I really like this method for working with negatives and positives, alright? We're going to represent integers using colored counter model. So using the colored counter model, each positive will be represented by a black dot, which we will be using, and each negative will be represented by an open dot. Now I'm going to be using red dots. Okay, so mine are going to look more like this. Okay, so they're not open, they're just red dots and black dots. Now, one thing we notice in this first example, I'm sorry, I'll read this. Oppositely colored counters, one red and one black, neutralize or cancel each other out. Hence, the following is true. So if you have a red dot and a black dot, what is its total value? Well, they would cancel each other out. And you could cross them out like this. Maybe you like to just cross them out this way. But I actually do cross these out. And each of these represents a 0, like this, okay? So the total value of this particular example is actually 0. Now I call that also a 0 pair. Just keep that in mind. How many 0 pairs are there in this? And when you add up a bunch of zeros, what do you get? You still get a 0, right? But we got to consider what we have left. Is it a black dot? Is it a red dot? Blacks are positive, reds are negative. Sometimes we have more negatives than positives. Sometimes we have more positives than negatives. It doesn't matter, just we have to zero things out. So in this next example, determine the integer represented by each of these loops of colored counters. So I'm just going to go through these and find all of my 0 pairs. Now I'm going to cross these two out together, these two, and these two. And what am I left with? Well, I'm left with this one right here, which has a total value of 1. And yes, if you wanted to, you could be like, well, I'm going to write that as a positive 1. That's okay. But the total value of this is 1. Alright, so determine the integer represented by each of these loops of colored counters. So you see the example here on the left. I'm just going to use the same exact strategy that we did on that last example on this one. So again, the first thing I want is all of the 0 pairs. Now, I should ask this, okay, so just take a look at this. How many 0 pairs are there in this set? And the reason I want this question is because it's going to help us determine the final answer, or the total value of this model here, okay? So how many 0 pairs? There's 1, 2, 3, 4, 5. And what do we got left over? So, again, that'll be the answer to this, but how many 0 pairs are there? Well, I just counted 5 0 pairs. Well, what's the total value of 5 0 pairs? It's 0. So what am I left with? I got these two right here that are left over, and they are negative values. So they're negative. How many of them are there? There's 2 of them. The total value of this is -2. Alright, represent each number in at least 2 ways using colored counters. Now, they use these ovals. You could use circles if you'd like to show each set. And since I do have a nifty tool for this one, I'm going to be using, well, I guess, ovals. Now, you know, if you wanted to, you can make a circle. It's not going to matter. And actually, I'm going to do this 3 different times. And the reason I'm doing that is because the first one should be really easy. It's a value of 2, so just put 2 positive counters in there. That would be those 2 right there. Now, if I take some negatives on this one, right? Doesn't matter how many, something like this. Now, I need the total value of this thing to be 2, right? So what this means is I need to match each of these negatives with a positive. Now, if I kept it like this, I would have 0. So what do I need to do to make it have a value of 2? Bam, just put 2 more in there. So if I wanted to do the same thing on this one, and you may show it differently if you'd like. 1, 2, 3, 4, 5, 6, 7, 8. So I got 8 negatives. So how many positives do I need? 1, 2, 3, 4, 5, 6, 7, 8. Now this, again, gives me a value of 0. But to give me a total value of 2, I need 2 extra positive dots on this one. So all 3 of these examples have a final value of 2. So take a moment here and see if you could find a way to show a negative 3, I'm sorry. We're going to try to do this 3 different ways just because the first one's so easy, right? 1, 2, 3, and we're done. But try those other 2. And yes, I'm using negative. I'm using red to represent the negative counters. But try positive ones, alright? Okay, hopefully you have that done. Now we need a total value of negative 3. So if I saw something like this, again, I could pair them up with negatives in order to zero those out. But then I would need 3 more over here so that the total value of that oval right there would be a negative 3. So the same thing on this one. It doesn't really matter where you put them. Maybe you want to make a fun pattern out of it. Maybe it's not fun. I don't know. Something like this, okay? And that looks pretty. And this, again, has a total value of negative 3 because we have these ordered pairs like this, right? There's a 0 pairs. There's a 0 pair. There's a 0 pair. And what are we left with? These 3 negatives. Now this is a really good question. What colored counters would have to be added to this set to make it a negative 4? And it shows it here on the left. You can pause the video and read that. But for this set, what I would need to do is figure out how many 0 pairs there are first of all. Because it's going to show us what cancels out, right? There's 1, 2, 3. Now if I wanted a total value of negative 4, I would need to pair this final positive remaining counter with a red one, right? So now that cancels out, but I want a total value of negative 4, so I'm going to need 1, 2, 3, 4 of these red counters. And now this has a total value of negative 4. Now the final question is, could this be answered in more than one way? It definitely could. And that would happen by just every time you add, or you could add more of these black counters like this, but if you did, you'd have to combine them with red counters like that so that they would zero out of the problem. And of course I've been using blue to strike those as 0 pairs. And see, so this is, I've added more red and black ones which have canceled as 0 pairs, but the total value still is negative 4. Alright guys, that completes this worksheet. Thanks for watching. I hope it helped you guys out. Again, if you need to rewatch any of those parts, we're going to be dealing with a lot of negatives here in this unit. Not only with whole numbers like we have been, but also probably some fractions and decimals. So expect that later on in the unit. It may come in the next unit, but in any case, be prepared for it. We're going to be seeing more negatives as we proceed through the next 2 units for this class.